Previously, the Johnson module was used. Then the Fenwal module replaced it. Note the ground terminals, the THS2 terminal, the PV1 terminal, the MV3 terminal, the Blind 6 terminal, the Sense 4 terminal, and the Spark terminal on each module. They have matching terminals and matching sequences of operation. The Fenwal has a diagnostic LED and rectifies at 120 volts for a minimum of 0.3 microamps, compared to the Johnson module's 24 volt rectification at 0.15 microamps minimum. The sequence of operation begins with a 24 volt AC call for heat arriving at terminal THS2. During step 2, the LED flashes once, while verifying no microamps were present at terminal 4. Step 3 is a delay of 4 seconds to purge the combustion area of gas prior to a trial for ignition, known as pre-purge. Step 4 is the trial for ignition, which allows 24 volts AC output from PV1 and spark for up to 50 seconds. Step 5 occurs within that 50-second trial, when rectification of a minimum of 0.3 microamps is present at sense terminal 4, causing the sequence to proceed. Step 6 occurs when pilot rectification is confirmed. 24 volts AC is output from MV3 until either rectification is lost or the call for heat is removed. Step 7 occurs if rectification is lost during the MV output, but the call for heat was never interrupted. After 15 seconds of interpurge pause, the module restarts at step 4. In step 2, if microamps were present before a trial for ignition, the module locks out and flashes the LED 2 times, pauses for 3 seconds, and repeats this until the call for heat is reset. In step 5, if the microamps never reach 0.3, the module locks out and flashes the LED 3 times. It pauses for 3 seconds and repeats this until the call for heat is reset. In step 7, if the module recycles 5 times in a row during the same call for heat, the module locks out and the LED remains on solid until the call for heat is reset. When no call for heat is present, the gas input to the gas valve is stopped at the pilot solenoid. The pilot, module, and specifically ground terminal 5 should all be well grounded. Also note the blind terminal 6 has no foil traces to it on the board, so it is a terminal with no connectivity to the module. The call for heat is shown here, arriving at terminal THS2. This 24 volt AC input triggers the module's sequence of operation to begin. In step 2, the LED will flash 1 time as the module verifies there is no rectification at terminal sense 4. After a 4-second wait called pre-purge, 24 volts AC is sent out from PV1 to the pilot solenoid at the gas valve, and spark is sent out to the pilot assembly. The pilot solenoid opens, sending gas to the pilot assembly, and the spark ignites the gas, creating a pilot. Note the pilot contacts the flame sensor when lit, generating microamps. When the microamp rectification of the pilot exceeds the minimum of 0.3 microamps, the module allows the output from MV3 to the main solenoid of the gas valve. Also, the spark output is terminated when the pilot is rectified. Typically, the microamp current will be much higher than the required minimum in a properly functioning oven. The main solenoid of the gas valve opens, and gas is sent to the main burner. Notice the main burner output is regulated by the valve's internal regulator. but the pilot gas output is controlled by the screw under the cap next to the pilot output. If rectification is lost during MV output, the module stops the MV and PV output. The gas valve closes both solenoids, and the pilot and main burner go out. The module pauses for 15 seconds, which is called the interpurge, and then restarts at the trial for ignition. If the module recycles 5 times, it locks out and the LED remains on solid. This is typically caused by a short on the MV circuit, such as the panel heat indicator light or the MV solenoid itself. If the pilot comes on and goes out shortly after, disconnect the MV terminal wires at the module and reset the call for heat. If the pilot stays on, check for shorts to ground by connecting the valve only or the light only. If rectification is sensed during a self-check, the LED flashes 2 times, pauses, and repeats that code. This is a fault code that typically is caused by a pilot solenoid sticking open. When the pilot solenoid does not close 100%, a reduced pilot can still rectify, and the module will lock out. If the pilot remains lit with the unit turned off, the gas valve must be replaced. If the gas valve fails open, verify the axial cooling fan is working properly and the unit's control side is not exposed to a heat source, such as a range or a charbroiler. If during the trial for ignition the module never rectifies the pilot, it will lock out and flash 3 times. To troubleshoot this code, begin by observing the pilot. If the pilot is lighting but the code still comes up, check the microamps at terminal 4. Put your meter in series with the disconnected wire and the empty terminal, and while the pilot is lit, record the microamps average reading. If it is below 0.3 microamps, check the flame sensor for carbon buildup, a damaged sense wire, damage to the flame sensor insulator, the grounding of the pilot or the module, and finally the gas pressure at the pilot. If it was above 0.3 microamps, but the module still locks out, verify ground, and if it is present, replace the module. If during the trial for ignition, the pilot does not light, but the spark is present, check the PV input at the gas valve, the pilot gas pressure at the pilot assembly, or the spark gap. If no spark was present, create a jumper wire, and ground one end, while holding the other end in a pair of insulated pliers an 1/8 inch above the disconnected spark terminal. When the call for heat is reset and the module enters the trial for ignition, the spark should arc from the spark terminal to the grounded jumper. If it does not spark to the jumper, verify ground from ground 5 to the unit and try again. If no spark is present, replace the module. If a spark is generated to the jumper, but not to the igniter wire, verify ground at the module and at the pilot, as well as inspecting the spark wire and igniter for damage. If the ignition module does not operate in the way described in this training, leave the unit in cook mode with the fan running and directly feed from the transformer secondary hot terminal to terminal 2 on the module, initiating a call for heat with no resistance possible from any control circuits. If the module works with a jumper, find the resistive contact and replace the component responsible.